Okay, we're going to start winding the toroids for the 49-to-1 UnUn matching transformer for our end-fed half-wave antenna. To start off with, we're going to need some wire. This is 16 gauge Remington magnet wire. It's enamel coated, solid copper, and this is what we're going to wind with. We're going to need around 5.5 feet total because the primary is going to be doubled back on itself, and I'm going to go ahead and cut out about 5.5 feet. Then we'll get back and start winding the coil. Okay, I've got the wire cut out now, and we're going to fold it back about 10 inches on itself. So before I do that, I want to scrape off the insulation because it's easier to scrape off before we do that. And I'm going to put just a mark here. That's the center of the fold. And I want to scrape off about, ½ inch to 1 inch of insulation on each side there of that enamel. So I'm going to go ahead and start doing that. Just going to use a knife blade, you can use a razor blade, you can use sandpaper, whatever you want to, and just start scraping off the insulation there. Want to get all that off so we make a good electrical connection later. Creates a good little mess. Just clean that up. All right, so that should be at the 10-inch mark. We'll fold it back on itself like that. Then we'll start twisting this. I'm going to put a little piece of tape down here to hold the wire together so we can start twisting it. This is just temporary. We'll take that off here in a few minutes. I'm going to put some pliers on this to hold it while we're twisting. Get my little old vice grips. Just lightly clamp it on there. We'll take a screwdriver and put through the end of it here, and then just start twisting. It's not a certain number of turns, it's just to get it twisted over on itself, because this is both part of the primary and part of the secondary for the UnUn. And why is this an UnUn? Because it's unbalanced on both sides. It's an unbalanced source to an unbalanced load. Since this is an end-fed half wave, it's not a balanced antenna. Okay, so there, got a pretty good twist on it there. And now we can start winding that. Go ahead and take the tape off of here now. Don't have enough hands. Now, and we'll unwind this a little bit. This end right here, and we need to go ahead and strip that back as well. But this end right here is what's going to go to the center of the SO239. So we'll go ahead and strip off that insulation too. Get it all good and shiny. Expose that copper. And you can use, like I say, sandpaper. You can use a Dremel tool. Whatever you want to get that enamel off of there. It doesn't really matter as long as you get it clean where it's nice, shiny copper like it is right there. Okay. Get all that out of the way. Now, we're going to be using two toroids. These are FT240 43s. Now the 240 is the diameter. It's 2.4 inches outside diameter. The 43 is the mix of the materials. And this works very well for the HF frequency range. And what we're going to do is we're going to tape these two together and before we start winding them. I've got some pieces of black electrical tape. It don't have to be black. Whatever color suits your fancy. Just stick it through the center, get it started, get it wrapped over, pull it tight, wrap it around over on itself like that. And we got one side of it wrapped. Do the other side the same way. Doesn't have to be precise. Just get the toroids lined up best you can. No precision to it at this point. Now, we've got the two taped together into one unit. Now we can start wrapping this around. Put this in the center here because that's going to be, like I say, the center conductor for the SO239 for your coax there. Get this pulled in tight here while we're winding it. All right. I'll cut off the excess here. So we'll wind this through the center. We need two turns. We want to get it as tight as we can. Okay, so we got, there's where we start. This is one turn, this is two turns. And we'll put another zip tie there to hold that end in place. And we'll cut off the excess. Doesn't have to be perfectly spaced. As long as it's going through the center there, it's a turn. All right. So again, this is going to connect to the center of the SO239 connector. And then this here is going to connect to both the shield of the SO239 and also to the ground of the antenna. And I see some enamel on there I didn't get off. Clean it up a little bit more. So we'll go ahead and continue winding. So since this is both primary and secondary, we're going to count those two turns, and we're going to wrap 5 more on this side here. So we'll bring the wire through. Pull it tight. So that's 3. Four. And just keep it tight as you go. Keep tension on it the best you can. Now I've lost count. So we've got We got the 2, 3, 4, 5, 6, and there's 7. So we've got 7 on that side. So we're gonna go through and then up and over, wrap the opposite direction, going the other way. So here we've got, go ahead and scrunch these together just a little bit. All right, there we go. All right, so there's 1. Two. 3. 4. 5. 6. And there's 7. And we got a little extra wire, which that's fine. It's better to have too much than not enough. So we got a few inches longer than what we need. But we got the coil wound now. And you can see here we've got 1, 2, 3, 4, 5, 6, 7. We got 1, 2, 3, 4, 5, 6, 7. So we've got a total of 14 turns. And that's our coil. I'll go ahead and put another zip tie on here to hold this wire in place. All right. And cut off the excess of the zip tie. And that's it. I mean, there's no magic to it. Just takes a little time. Doesn't have to be perfectly spaced or perfectly aligned. It's going to work just fine. You can look at it here. Main thing I look at is the crossover point here. I try to make sure it's, 180 degrees. And again, that's all right. So that's it. We'll put that inside our box. We'll pick up from there. I'll solder some ring terminals on these, crimp them on a little bit, cut this one to length, and we'll get it inside the box. Okay, we've got our ends cleaned off here now, ready to solder. Going to be putting some of these ring terminals on, these two, and on this one here. This one will be soldered directly to the center of the SO239 connector, so we won't need a terminal on it. Waiting on the soldering iron to heat up. I've trimmed this one more to length. It's probably still a little bit long, but we'll deal with that. The box I'm going to put it in is a 4x4x2 junction box. I bought this at Lowe's. Man, the prices on these things keep going up. The first one I bought was around $10. This one was over $12. And it's just a 4x4x2. 4 inches square, 2 inches deep. Plenty of room for this 49-to-1. Now, other thing I haven't mentioned, other than the hardware, is a 100 picofarad capacitor. This helps to flatten the SWRs all the way across the bands from 80 meters to 10 meters. It makes it flatter, gives you better SWR response all the way across. So we'll be putting that in across the terminals for the center conductor and the shield of the coax in parallel with the transformer here. All right, let's go ahead and see if we can tin the connectors here. I think the soldering iron is hot now, and see how it does. Put a little on the tip itself. And there it goes. And I think I mentioned before, this wire is 16 gauge. This should work fine for anything up to QRO. So we can get all this on here. And that one there will be the center conductor. And this one here is the one that goes to our antenna, the radiating element. Okay. And we've got those tinned. I'm going to take these yellow insulators off because we don't need them. These should fit right through. These are 1/4 inch diameter by 1 inch long hex nuts. And got the hex bolts, and we've got the nuts and the flat washers to go with them. And that fits perfectly through there. So I'm going to put this on here. Going to crimp it a little bit. And then we'll solder it. So we'd have a good mechanical as well as electrical connection. Put a little dab of solder on there. Soldered on there now. We've got 2 more to do. Got one small one here because of the screw for the SO239 is so much smaller. I'll go ahead and get that one crimped on there. And then this one here is for the ground terminal, which will also be a 1/4 inch. Okay. Now we'll get those soldered on. Put a little solder on the... starting to flow. All right. We'll let that be cooling. And we can go ahead and mark and drill everything here now. I'm going to put the SO239 connector right in the center of the bottom here, about right there. I'm going to put a ring terminal here to hang it from in the center there, and the antenna connector bolt I'm going to put approximately there. Real precise markings, huh? It doesn't have to be precise, it just has to be functional. I'll do the same thing for the ground about right there. So let's get our drill And I use a step drill. I find it to be very flexible and functional. And you got all your different sizes. I'm just gonna get the hole started here. Cut through this plastic quite easily. All right, that's needs to be a little bigger. All right, and let's see how that looks. That looks good. Got plenty of room. Guess you can see that there. Get the right angle, but it fits down in there. Now we'll drill some holes. I am going to change bits for the holes there. I think this one here is about the right size. Maybe one size bigger, let's see. That was a 1/8 inch. And this one is a 9/64. Oh, that's almost perfect for that hole there. And that's what we're going to be drilling. A couple of holes there to put the screws through to fasten it. And what I normally do is drill the first hole and then put a screw through it and use it to align for the second hole. Try to get it where the edges are parallel and get a hole going there. And there's the first hole drilled. And I have some 6 30-seconds by 1/2 inch screws and nuts. And let's see if this won't just fit right through there. Oh yeah, perfect. Perfect, perfect, perfect. So we'll put that nut on, that first nut. Get it started. Okay. Now we'll, that'll help us hold it in place while we drill for our second hole. I'll go ahead and tighten this up just a little bit. And get that where it's parallel. Just make points for neatness, I guess. And this screw up here is where I'm going to attach the shield on the inside. All right, so we got that one drilled. We'll put that screw in a minute. Now we need a 1/4 inch hole for this bolt and for the other two bolts. So we'll switch back to the step drill. Get that going right here. Whoa! Got to hold on to it. Be slinging stuff everywhere. Just knocked my pretty red-handled screwdriver off. Let's see if that's big enough. Oh yeah. Oh yeah. So what we're going to do, well, we need to drill all the holes before we start doing anything yet. Do the same thing up here. Get a 1/4 inch hole there. Another 1/4 inch hole there. All this really good smelling melting plastic from the drilling. That's good. That's good. All right. We'll put in the ring terminal at the top. This is what you can hang it with as a strain relief. That way you don't put any strain on your electrical connections. Just put that through. We'll adjust the nuts here in a second. Almost perfect. All right. Now, got that bolted in. Okay, we need to put a dab of solder here on these, where these two wires connected together. They need to be at the same potential. All right, we'll let that cool off. Then we'll check it with the ohm meter out here at the two terminals to see if we've got continuity. All right, so, all right, now we got continuity. All right, now we need to get this capacitor connected around this other wire here. Wrap that lead around, and we should be able to solder that in place now, hopefully. All right, now I think we got a good connection. Now let's see if we can get this repositioned in here. Let's get this bolt in here. Then we can slide everything over. Now, get this screw through here. Get this meter out of the way. We won't be needing that. Hold that in position with my finger. All right. Now we'll heat that up. That center connector. All right. All right, now we've got our capacitor, we've got our center conductor, we've got our wiring finished in our 49-to-1 UnUn, and I want to show you what the resistance looks like. That's a dead short right there, just touching the two leads together. If I go to the center conductor, it's going to show a dead short there also. It should also show a dead short here and a dead short here. You say, well, how does that work? Well, it's because the RF is alternating current. It's not direct current. The ohm meter is direct current. So what we've got here, we've got the center conductor, which is one of these two wires here. We've got the 100 picofarad capacitor right here that's in between the center conductor and the shield. And then we've got these two wires are electrically connected here. So this is the same as this. So you're going to have a dead short here to here. Also, you've got a dead short between here and here. But this primary winding here is inducing alternating current into the secondaries. We've got 14 turns of secondaries here, 7 on each side. 7 times 7 is 49, so we got 49-to-1. So we're going to connect our NanoVNA to verify that we do have a 49-to-1. And how do you simulate an end-fed half-wave antenna? Well, an end-fed half-wave antenna is approximately 2,500 ohms, 2,400 to 2,600 ohms. Okay, I've got two resistors in series here, and there should be around 2,450 to 2,500 ohms. And it's 2471, which that's going to be pretty close to what an end-fed half-wave is going to read, somewhere in that neighborhood. So we're going to use this as our test load. I'm going to see if the transformer steps it down to the 50 ohm range, which is what our radios are looking for, somewhere in the 50 ohm range. So let's put this across the two antenna lead connections, and then we'll test it with the NanoVNA. Because once we get it on the transformer, the ohm meter will not be able to read it, because it'll look like a dead short to the ohm meter, because it's passing DC only, not AC. Need to add a little length of wire here to the resistors. Otherwise it won't be long enough to go across these two terminals. We'll connect one end down here to the ground, and we'll connect the other end up here to the antenna, where the antenna would go. All right, so we've got our 2,470 ohm load on there now. And we've got our NanoVNA here. Now, if we look right here, we're at 16 megahertz. Let me get it down to the 14 megahertz range. And that's 14,255 right there. That's reading 35 ohms. And that's pretty much what it's reading all the way across down there, is around 35 ohms. 40 meter band, 37 ohms. Let's go on up. It starts going up. Let's get up into the 17 meter, 18. There's 18.132 megahertz, and we're reading 42 ohms, and it keeps going up. 29 megahertz is 147, so it's about 3-to-1. So this transformer is doing what it should. It's stepping it down to a usable range, a tunable range, and we will connect this up to our antenna, and we'll see what it looks like in the real world instead of just on the meters here. Okay, we've got our 49-to-1 UnUn out here, the 2-core that we just got through winding and testing. Got it connected up to our end-fed half-wave. We do have a counterpoise on it here. It's about 0.05 wavelength, around 6 feet. Some people say it helps, other people say it doesn't make any difference. If it doesn't make any difference, I'm going to use one. If it helps, I'm going to use one. But we've got our end-fed half-wave about 20 feet up there on that limb, and we're going to see what kind of readings we get on SWR on 40 and 20, and see if it's workable on any of the other bands as well. It may not be, but we should be able to get it 40 and 20 without any problems. And then we can use a tuner to bring it in on the other bands. I do use my common mode choke that I built in the other video. And all the components that you see here will be in the components list in the description on the video. So let's get on the radio and see how this 49-to-1 is working for us. Okay, we've got our 49-to-1 UnUn connected to our end-fed half-wave. And we're going to test it out on all the bands. Here we are on 10 meters, and I do have an antenna tuner in line because there's not an antenna tuner in this radio. This is a Kenwood TS50S, does not come with a tuner, so I've tuned it in with the MFJ Deluxe Versa Tuner 2, MFJ 949E. Be able to see here on each of the bands that it is tuned very low SWR. So let's key it up here on 10 meters, and you watch the meter here. This is cross needle meter, and it doesn't move at all. It's 1-to-1 SWR on 10 meters. So we'll go ahead and change down to 12 meters, tune it there, and show you what it does there. Okay, now we're on 12 meters. I'll turn the volume down here so you can hear me. And got it tuned in. And watch the cross needle here. We're putting out 100 watts. And we're coming up to about a 1.1-to-1, 1.1-to-1. So again, we're being able to tune it flat across the band. Let's go on down to 15 meters. And we're down to 1-to-1, below 1.1-to-1, so it's virtually 1-to-1. So that was on 15 meters. Let's try 17. On 17 meters, we're reading right at 1-to-1. I don't know if you can see this meter here or not, but it's staying down below 1.1-to-1. So very tunable across the band so far. We'll go on down to 20 meters. And at 20 meters, we'll put it on what it liked prior time and see if it's still good. On 20 meters, it's running about 1.2-to-1 at that current tune. And the tunes are repeatable. So that's doing very well, I think, for this 49-to-1 UnUn. We'll go on down to 40 meters. Okay, at 40 meters, tune it down to 1.1-to-1. So working very well on 40 meters also. Okay, we've got through testing our 49-to-1 UnUn that we built from scratch. It checked out very well, everything from 40 meters to 10 meters, which is the antenna here is actually a 40-meter end-fed half wave, so that's exactly where we expected it to operate. Very low SWR, below 1.2-to-1 on all those bands, so very, very workable. If you haven't already, click on the like button. If you haven't subscribed, be sure to do that. Share it with others, leave a comment, ask a question. I try to respond to all those that I can. This is Kilo Mike 4, Zulu Kilo Bravo saying, have a blessed day.